This is a video on momentum, force, and impulse. So these are actually part of Module 2, Dynamics, for the Year 11 Physics course. And I thought I'd combine all these three concepts into a short video, just demonstrating that they're all related in some intrinsic way. So I'll start off with momentum. Now, momentum in layman's terms, it's a simple concept to picture. It's basically how difficult it is to stop something in motion. And mathematically, it's a straightforward formula. It's just P equals mv. The P is momentum. It was actually given the letter P by the French mathematician and physicist Joseph Louis Lagrange, coming from the Latin word impetus. Impetus comes from im and pelle. So im means inner, and pelle means to push forcefully. So it's like the inner motion of an object, the inner energy causing motion in an object. So that's momentum P. M is mass, as is the case in physics typically. And mass has SI units, kilograms, kg. And V is the velocity of the object that's moving in meters per second. And so therefore momentum has the units of kilograms meters per second, okay, because it's kilograms multiplied by meters per second here. And what this simple formula tells you is that a large mass moving with a large velocity has a large momentum, and vice versa. And just a little extra thing here, when you do HSC physics, when you approach speeds that are close to the speed of light, so very high speeds, P equals mv actually becomes P equals mv over the square root of 1 minus v squared over c squared, where c is the speed of light. C is a number. It's about 3 times 10 to the 8 meters per second. That's for the HSC. So let me now talk about force. So where force comes in. So momentum of an object changes along its motion. Okay. So let's say there's a ball being tossed into the air. Its momentum will be changing over the course of its motion. And this formula here is basically the momentum of an object at an instant in time, right? Whereas here, the momentum, as you can see, is changing because the ball's motion is changing. So it makes sense to talk about the rate of change of the momentum. So the rate of change, so the change in momentum, delta P, with respect to time. So delta, this is capital delta, it's a Greek symbol, and it means changing. So this tells you the change, this is telling you that the momentum is changing with respect to time. And the change in momentum is simply, so back to this formula here, momentum is just mass times velocity. The change in momentum is the momentum at the final part of its journey, of the ball's journey here, minus the initial momentum at the beginning of the journey, divided by the change in time. So it's final minus initial, final velocity minus initial velocity. Let's now bring in Newton's second law of motion. So we know that to cause a change in momentum, you need a force, right? So therefore, force, and I put a vector here, right, force is a vector, because it's the force acting on the ball in this case is changing, right, along its trajectory, acting in a particular direction along the motion, is just that delta P over delta T. What we had before, we'll bring that in as well. mv final minus mv initial over the change in time, delta T. Let's take out the n, because it's common to both the VF and the VI, over delta T. So the m is a constant, right? It's intrinsic to the ball in this case. It's not changing, so we take it out of the parentheses. And from basic classical physics, mechanics, the change in velocity v final minus v initial over time is just the acceleration. And so that's how momentum and force is related. It's through Newton's second law of motion, F equals ma. A very neat, simple derivation there. Last thing I want to talk about is impulse. So impulse, from in layman's terms, is basically a measure of the change in momentum of an object when a force is applied to it over a certain period of time. So in other words, so let's go back to this formula here. So impulse is basically a measure of the, as I mentioned, the change in momentum of an object when a force is applied over a certain time. So let's take this delta t over to get this, and by definition that's the impulse. Okay, impulse is also a vector because force is a vector. And there we go. So that's how momentum, force, and impulse are all related.